Alright, guys, girls, I want to continue with review today. I got a couple of proofs that I want to, you don't have them yet. If you have a sheet of paper, you can write them down.
Ich wohne in Denver.
So, since we started proofs versus... Oh, and I got to record this class because I didn't record last week.
Die älteste in meiner Familie ist meine Urgroßtante. Sie ist 600.
Wann bist du morgens in der Schule?
So if you have a sheet of paper, it'd be great if you get it out. So I'm just going to start out by putting the diagram up. I'm not going to do anything else. I'm just putting the diagram up. So if you have a sheet of paper, you want to take notes, go for it. If you want to just chill and watch, it's up to you. Yeah.
This diagram is showing.
Okay. So what are some go-tos right away when you look at the diagram? You don't even know what you're proving. You don't know anything else. Seamus, what do you got? Yep. So some go-tos, you have angle 1 is congruent to angle 2. And you have angle 3 is congruent to angle 4. And those are both because of vertical angles. Okay? Now, do we know what we're even proving yet? No. All I did is we're looking at the diagram. I hadn't put purposely up there our givens yet or what we're trying to prove. But I just wanted you to see. Now, do vertical angles tell us anything about lines being parallel? No. Okay, so that's all we can say right now. Correct? Is anybody, so is it okay that I put this reason up here before I even put givens? Sure, it's not going to break anything. So this is what we want you to prove. We want you to prove that angle 1 is congruent to angle 4. Okay? That's what we want you to prove. The next given is this. Okay? So things you know. You know that this is congruent to this. You know that this is congruent to this because of the vertical angles. And then we tell us you know that 2 is congruent to 3. Okay? Yeah?
Why didn't we say that now the top line is congruent to the bottom line because of alternate interior angles? And then you could say that 1 is equal to 4 because of alternate exterior.
We are definitely going to get there. But I got to get from 1 to 4. So go ahead.
Right, so that's what I just did.
Say it one more time.
So 2 is equal to 3. So if we know that 2 is equal to 3, then the top line is parallel to the bottom line because of the alternate interior angles.
Okay. I really, really like what you said. But this is what I would caution you against. I don't have my lines labeled yet. There's nothing to say. Like if I had line L and line M, I would go right to what you just said. And I agree 100%. But I would not add anything to it yet.
Why not?
It's just kind of messy. Because go with everything the diagram says. I love what you're saying, though. And I agree. But because I don't have those 2 lines labeled, I haven't named them anything. Can you? Yes. Name one Fred and one John. I don't care. But George, okay. Go ahead.
Couldn't y and 4 be equal because of transitive? Because y equals 2 equals 3 and 3 equals 4.
There you go. So, I'm going to go the long about route. You're absolutely right, and you don't change what you're saying. So, I think I could say this right here. I could combine those 2 together right now, and this is going to tell me that angle 1 is congruent to angle 3, and that's your transitive property.
Can you say that 1 equals 3 equals corresponding angles as well?
No. Well, they are corresponding angles, but you don't know corresponding angles yet because you don't know these lines are parallel. Okay, so be careful. That's what I'm trying to guide you away from. Don't make the assumption there. Try and prove everything you know before you start adding labels. Cool? All right, so 1 is congruent to 3, and then there's something I can do here as well. So that was transitive. What can I say there? 1 is congruent to 4, and that's transitive as well, and we're done. Now, let's go back to what you are saying, because your mind works faster than mine, and that's okay. You have to have someone to make fun of, and that's got to be me every time. All right. Now, let's say you're kind of spinning your wheels on the problem. You've gone through everything you've done. This proof is done. But some things that we might want to say is they might tell you that you have line L and you have line M. So they might want you to say that L is parallel to M. Okay? So at this point, this proof is totally done correctly. We have lines labeled. So hang on. So with that known, right here, that could have been proven right there. Why? That's alternate interior. Now let's say you didn't see alternate interior right there. Could I prove it here? Why? Corresponding. Could I have proven it here? Yeah, corresponding or alternate exterior, right? Okay, so I want you to think about this. Don't go and put a label until you have exhausted all of your stuff. I think it would be the better way of going through it. And now there's a couple of the math teachers that, and I don't agree with this. So if I don't agree with it, I must be right. Just saying. So, stir up fight. Lee, what do you got?
Sort of like in real life, what you said about labeling. You have to exhaust all your options for labeling.
Okay.
It's a quick comment.
That's
Being
right.
really
Blame
lost.
himself.
What?
Part of your final Monday.
Well, what part? What part?
What part? Where you put your name and you bubble everything in. I have no idea.
No, the written part.
The written part. Okay, sounds good.
What?
Say, what is the written part?
Yeah, you got to write a paragraph about stuff.
No.
Story about two
No,
lines.
not math and writing.
So these two lines walk into a bar.
These two lines.
The really weird part about this story is the lines exist only in one dimension.
And they
So
don't
the
have
bar
names.
that they should be
Mr.
running, so they
Scrubber,
shouldn't both be able to run into a bar.
It's an hour 8.
And
All right.
also, they're more running into a point.
Here we
from their
go.
perspective.
So there's you remember when we first started proofs and we would have like step 1 and then you'd have to put the reason and then their next step would have the reason, you'd have to put the answer, and it was like we had like 5 steps. Well, there's some teachers that and again I struggle with this because I like the thought process that's taking place here. Do some people take a longer time to think through something than others? Absolutely. Does that mean they're wrong? No. So I have a hard time with if a teacher were to say, okay, prove this to this, and the teacher was able to do it in 4, and the student took 6 steps to get there with all legitimate things. And I'm not talking about the kid that says A is reflexive to A and B is reflexive to B and C is, doing all of the ding-dong stuff. I'm not talking that. I'm just talking there's a logical progression of thought that can go into these. Some people might take a little bit longer before it's that's it, versus someone else who's got it right away. So I struggle with taking points away that if I could do it in 5 steps and you take 7, I struggle me taking points away. And that's just me as a person. That's not, and it's a teacher, but that's where we're at. So that's where I'm at. So hey, does everyone feel okay with this?
Yes.
All right, let me move on to the next one.
The first one that I understand why we can't.
Oh, and I will be in my office today, right over here after school. If you wanted to swing in for extra help, so it just to let you know. I only have the diagram up there. So if the diagram's up there, what's the only go-to I have right now? Yeah. Good. L. Yeah, angle 2 is congruent to angle 3. vertical angles. So vertical angles are a go-to. It's a gimme. It's there. It exists for you. Okay? So what are some other things that we might be looking at up here? Being the two triangles are not the same, I'd say where we might go is we might say that that is congruent to that,
Parallel.
or the parallel.
Where you put in the test.
Okay, maybe.
Because
So-
they're free and
So that might be where we're going with this problem. So I haven't even looked at the givens yet, but I know that, hey, we have this already. It's a go-to. I feel good about it. I've listed it before my givens, and that's okay. It's something that's there. So I'm trying to direct, and some of you don't need this, but some of you do. Some of you might want to just look at the diagram first, going, what can I conclude off the diagram? And the big gimme there is the vertical angles. Okay? So we are indeed going to try and prove that AB is parallel to CD. So with us thinking that, where would we probably need to get to as far as this goes? Yeah,
1 is equal to 4.
1 is 4 because they're alternate interior angles, right? And we have to show that they're congruent. Now, let's see what our givens tell us. I bet you that angle 2 is congruent to angle 3 is going to help us out a lot. But then our givens, we have angle 1 is congruent to angle 2, and we also know that angle 3 is congruent to angle 4. These are both givens for our problem, okay? Then, now that transitive property is kicking in. So, without this, we can't get there, right? And it doesn't matter that vertical angles happens here, or in between, or down here. It doesn't really matter, but it's got to be labeled somehow. So now, if I combine these together, what can I make the conclusion off of that? Angle 1 is congruent to what? Angle 3, transitive. I could say angle 2 is congruent to angle 2. Yay, but that's not going to help us. What can I conclude off of then? Let's see, 2, 3. Can I go here? And what does that get me?
1 is equal to
Angle 2 is congruent to angle 4.
Angle 2 is congruent to angle 4. I'm sorry, I don't know why my brain farted for a
And
second.
then,
And that's transitive as well.
if you combine those two, then you get.
So then, these combine together to give you angle 1 is congruent to angle 2. That's also
We
transitive.
already knew that. That's our given.
Oh,
Trying to prove that 1 is equal to 4.
oh yeah, 1 to 4. Yeah, thank you. Boy, man, you make 12 errors in a day. Man, I tell you, they really are. All right, so what can we get to? Do we have enough to get to 1 to 4?
Yes.
Where?
In the second, the blue one.
The blue ones. I can get 2 to 4 in the blue?
We just said 2 is equal to 3. So then 1 is equal to 4 because of transitive. Just that.
Oh, why did I already say this? That was given. That was vertical angles. Oh, man, that's it. That was already up there. Oh, yeah. All right. 1 is congruent to 3, so that's going to allow this and this to be combined, right?
And 1 is equal to
And that's going to give us angle 1 is congruent to angle 4. And there's our transitive again.
4. AB is parallel to CD because of alternate exterior.
There you go.
Alternate interior.
Alternate interior angles. Okay.
But we get points taken off if we jump from to 1 to 4 instead of 1 to 3.
I think there was that theorem that where we started getting into that we could skip this and go, and I think some people have got that. We were talking last period, someone said, oh, that's theorem 5.3. That sounds great, but I don't remember what 5.3 says to save my life, and I'm the teacher. But they're probably right, but here was my problem. When I was in school, I used flashcards for my Spanish, for my Latin, and for my chemistry. And I never did it with math. So I couldn't remember the theorems to save my life, but I knew I could describe what was going on. So if you're the person that can make the jump, if you can make the jump, or if you can go from these to this, I think that's okay. And I think you're going to be correct. but some people might not see it right away.
Why did you take 2 languages?
Huh?
Why did you take 2 languages?
For fun. I took Latin because I wanted to be a doctor. I took it for 2 years. Huh? No, and Spanish became real easy because 65% of all, or something like that, of all Spanish is Latin. Something like that.
Can we do substitute and transitive?
Where are you substituting?
For the 1, 2, 3, 4. So like,
Yeah, it's a substitution. Yeah.
I'm just a little interested, just randomly. How did you end up teaching the medical careers class?
I was on a committee at Chaparral High School called School to Career, and we set homeroom twice a week where you could go see your teachers if you needed help. And so what we do sometimes during those times is each department had a month that they had to bring in guest speakers. So I was the representative for math to bring in guest speakers. And I went to my doctor and asked, would you like to come in and talk to some kids from 8 to 9:30 one day about being a doctor? He goes, no, but my senior partner would like to start a class. So I met with the senior partner. This class started in 1975 at Arapahoe High School with a guy named Dr. Sam Langstaff. And my doctor's senior partner had been talking at Arapahoe High School since 75 when it started, and now he was retiring from his practice and wanted to do the same thing at another high school. So that started at Chaparral High School, and then Ron Peterson was the principal at Chaparral High School. He was involved in it. He loved it because, one, I was writing grants, I was covering my stipend for it, and that was during the bad budget stuff. And so Ron was impressed that I went out and found out outside money to fund me to have this class go with hundreds of kids. And then when Ron Peterson was offered the position of director of schools in this district, he called me and said, hey, you want to bring that med class? I said, yep. So I came here. Now Ron Peterson is retired. Yeah, but I have so very little connection with those people at SHAP. Like, I became bad. Anyone who's ever left SHAP is like, oh, no, you're not cool like us anymore. It's kind of a good old boy club. Chaparral High School has a lot of cliquey teachers. They're like, oh, we're part of this group. And it's like, you're kind of a jerk. It's like, well, who are your friends, Chris? Well, I got doctors and lawyers and business people who are my friends. Why don't you hang out with teachers? Because all we do is sit around and bellyache about kids. Oh, yeah, well, I had this one kid that. That's how most teachers hang out and talk. And it's not interesting to me because I don't want to bellyache about kids or praise kids. I want to go out and talk about, football and baseball, and my doctor and lawyer friends don't want to talk to me about, oh yeah, well, I was in a trial today, or hey, I pulled out a gallstone today that was the size of a soccer. They don't want to talk about it.
Soccer ball.
Yeah, I'm just saying.
That's what
Were you gonna say
saying.
soccer ball or softball?
Both. It was 2 of them.
Oh my.
You would be
Soccer ball.
dead.
Person's dead now.
You could definitely get something like that. I mean, you can get
That's
goiter that's
sock.
big enough because you don't have iodized salt in your diet. So.
Holy cow.
Where all do you
Soccer.
get students from here? You obviously get students from Greek. Don't you get some kids from Overland and Arapahoe middle school class?
Grandview had 2 kids in our class. I had one from Regis, but the one from Regis failed because she stopped coming. Just saying. All right, diagram is on the board. 3 and 4 is a go-to, okay? So angle 3 is congruent to angle 4. Vertical angles, they exist. It's money. Now, things that we need to start thinking about how this problem could go is I could have this triangle here congruent to this triangle here, okay, which means I have a reflexive property. It might be that, so we have to think about that, okay? We also might have this triangle here is congruent to this triangle here. Okay, and that means that DC has to be a reflexive property. There could be all kinds of things that could take place. Other things that could take place, not knowing anything else, we could say that this triangle here is congruent to this triangle here. Those are all things that could be happening with this. Okay, so let's see. Let's go and see what they want us to do on this problem. Okay. they would like for us to prove that AB is parallel to CD. So in order for say AB is parallel to CD, it looks like right now it's trying to get us to get to that angle 1 is congruent to angle 2. If we get to that, then we can say that AB is congruent to DC because of alternate interior angles are congruent.
Not congruent.
Huh?
Not congruent. We're not trying to make them congruent.
1 and 2 we want congruent.
Well, you said AB is congruent to DC.
Oh, thank you. Again, error number 455.
On
Alright.
454.
Don't
remember
remember.
we the council decided that other error that you had that wasn't actually an error.
Gotcha. All right, these are my givens. Okay, so angle 1 is complementary to angle 3. Angle 2 is complementary to angle 4. We there? So I think some of you might be able to make the jump, but some of you might not be able to make the jump. And I think a good thought is this. Why? Yeah, these are complementary. That's the definition of complementary. Okay? And if you say that, then you can go ahead and state this.
Yeah, how can you say that?
What were your evidence to prove?
That 1 is equal to 1 and 3 are equal to 90.
Because they're complementary. 1 and 3 are complementary to each other. And 2 and 4 are complementary to each other. So complementary angles are 2 angles that add up to 90.
I didn't
So so those are my givens I put up there. So I can make that jump here, and then I can make that jump here because of a transitive. Okay?
Do you have to put the 90 degrees part to say that, like.
So this is not the necessary portion. But some of you might not see it not having that. A lot of you see it, and it's okay that you have that. And again, this is where I struggle, where some of the teachers are like, oh, well, they had 2 extra steps, so I'm taking some points away. But I don't know about y'all, but I think right there, that is something that is easy to see right away. As a whole, not as the individual. Agreed? Agreed? Okay, so then from there, I can go ahead and talk about this. Where? I need to plug either in for here or in for here. I have to pick one of them to plug in. Okay, don't plug in both because then you get angle 1 plus angle 4 is equal angle 2 plus angle 3. That's not going to help you. So pick. So maybe I'll plug angle 4 in here. And what property just took place there? Because it wasn't transitive. Substitution. Okay? And then what property took place here? Subtraction. Exactly. Okay? Now, why can I say that AB is parallel to CD? Alternate interior angles congruent. Huh? You can.
Do we have a testimony with them?
Yes. So, Seamus, what I'm trying to show you, though, is if you look at the diagram first, there's some go-tos, right? So list it. And then go to, okay, what are we trying to prove? Gotcha. What's given? So there's not any rules that say, hey, you got to list your givens first, because there's definitely things that should stick out and should come to mind, okay? And the vertical angles, the other one is on the next one is reflexive, okay? All right, next problem. Here's our diagram. So knowing nothing else, what's something that we know? It's a go-to. Yeah, UK is congruent to itself. And that is reflexive, right? So we know this. Okay? No, can't go do UC yet. Okay, so I haven't put any givens. I don't know what we're trying to prove. What are some other things you should start thinking about right now as far as this shape goes? What are some things that might stick out? Yeah.
That
Go.
DUK could make a 90 degree.
It could. What else? We could be thinking about HL. What's something that you could tell me that we might try and lead to for D, C, and K as a triangle? It could be isosceles. That might be something. If we're thinking about isosceles, we also might think that angle D is congruent to angle C. If angle D and C are congruent, that tells us that DK and CK are congruent because of our diagram. Yeah.
For the diagram doesn't have to have isosceles triangle.
No, I'm just trying to say what are some things that we could start thinking just by looking at the diagram, nothing else.
For the I mean like the angles are equal, the sides are equal.
Yeah.
Does that have to be an isosceles triangle?
Well, yeah, so B and I have won the shared side. I know reflexive, that's our go-to. But you have to realize that this and this can go either way.
But does it have to be an isosceles triangle for that?
Yes, that's definition of isosceles. Okay? So we can either go with the DK or the CK are congruent, and that would mean that angle D and angle C, base angles, are congruent. Or I could say that my base angles are congruent, and that would go to saying that my opposite side or my sides next to those base angles are congruent. So that's just where I'm going to. Do I think we're there yet? I don't know. I know our given is our go-to right now is our reflexive property, but I wanted to just to see what we could label or what we could start thinking about before we get there. Now, what if we knew this? Let's see, go here. What if we knew like this? And what if I knew those were congruent? What if those are things that were told to us? What could you tell me about KU and DC? We just had it on the test.
Bisector.
What kind of bisector?
Perpendicular.
Perpendicular bisector. If you have two segments that happen to be congruent to two other, or you have two segments congruent and then two other segments congruent and they're going to the same line, you are on the perpendicular bisector. Okay? So that's something else to think about as far as this problem goes. So if, and again, I haven't even listed any of the givens. I'm not looking at them. I'm just trying to get some things that we should pull going, yep, we could say this or that. Okay, so,
Mr. Rep,
yeah.
This is a really weird question. But what's the most complex shape that is in like geometry?
I don't know.
Well, like your best guess.
What's that?
Be on the test on this.
Math?
Like words.
Is it just all the semester?
Probably some proofs. Proofs? Probably some diagrams. I don't know. All right. This is what we're trying to prove. This is what we're trying to prove. You still with me? Okay, so let's list. We have a given. We have this as a given. DC is congruent to UK. That's given.
Why are we in Britain all of a sudden?
Wait. You said congruent, but you wrote perpendicular.
Perpendicular. DC is perpendicular to UK. I'm
But
sorry.
I thought that
I was
DC
confused.
and the UK were pretty good allies.
Good. All right. So,
Also,
because we know this, what can we start stating?
Obviously,
If they're perpendicular, what can we say? Yeah, so angle DUK and angle CUK are equal to 90 degrees.
Wait.
Okay, think about it. DUK, CUK are equal to 90 degrees, which means you could get to CUK is congruent to DUK. Okay? What's this definition? Why?
Definition of perpendicular.
Definition of perpendicular. Okay? Why can I state this then?
Substitution.
It's substitution or transitive. I'd probably stick with transitive because you have three things. 1, 2, 1, 2. Okay? So transitive would work. So that's a good go-to. So now you have this and this. Now, what should you start to be thinking about that's taking place with this? Yeah, hypotenuse leg could be taking place. Okay? Doesn't have to be hypotenuse leg. doesn't have to be hypotenuse leg, but it could be. The reason I'm saying that is because we have a 90-degree angle given. Okay? There is one more thing here about this. This says that U is the midpoint of CD. So if U, and that's given. Here's another given. So now, what can we conclude off of this? There you go. DU is congruent to UC, and that's definition of what? Yeah. So now I know this is congruent to this. Do I have hypotenuse leg? No. What do I have though? I have side angle side. Awesome. So now I can go ahead and say that triangle DUK is congruent to triangle CUK because of side angle side. And then I can go ahead and say that angle D is congruent to angle C. Why? CPCTC.
What? Wait.
CPCTC.
That's not a C.
Jeez.
You can't argue with that one. That one was definitely not a C. The A's at least sort of look like an A. Sorry, not to get too mad. But that was pretty bad. Like your other mistakes.
Pretty
are
high
good.
strung there, Lee.
I am. I know. I'm easily triggered.
You stay awake all night because Santa Claus is coming and you're scared?
No. Wait. Whoa. How do we make that? jump
Just
a lot?
anxiety, you know, like Santa Claus coming, I'm scared.
What?
What? Yeah, I'm.
Or the
Okay.
Thanksgiving turkey's coming.
Oh.
What?
No,
That was
no,
scary.
you're giving me back the nightmares.
Or
The Easter Bunny.
But it tastes
Or
so
it's
good.
loud booms outside because it's 4th of July, so you like my friend's dog and you crawl in the bathtub and hide.
That's what my dog did for the 4th of July.
All right,
Really?
so those are 4 genuinely good proofs that are very available that you could see on the test. Is there anything from the review you want me to take a look at? Things that I saw earlier. This is out of the review, so if you want to look at it, this is number 26. This is a good problem here.
Just gonna practice proofs all weekend.
It won't help.
I have no
Well,
time
that
to study
wasn't-
for finals over the weekend.
That's why I'm reviewing for you.
I'm road tripping and I'm driving half the time.
Why don't you try that?
I'm gonna go on IXL and just do
basically my sister needs to come home and she's
Mr. Sarah?
What?
How do you feel about
She
IXL?
needs a car. So
What is it?
Driving
Website,
hours.
IXL.
I don't know what that is.
It's a math.
Being
What do you mean?
airmail basically to.
I don't know what it is. I've never heard of it.
driving back.
You haven't heard of it?
You're just telling me it's a website that's a math thing. It means nothing to me.
What
Practice
math?
on it.
No, I'm
Oh, good.
trying that.
Practice it.
I'm gonna
driving
practice.
back.
All right, good. I don't know about it. All right, so things that this problem tells us. Shh. Number 26, it tells you that CE, it tells us that CE is the mid-segment, okay? So it says CE is the mid-segment, so I know that this would be 6 and this would have to be 8. Other things this problem asks for is for us to find this perimeter. They want to find this perimeter here, okay? So the perimeter is all the way around. So I know I have 6 and I have 8.
It does.
So it's at least 14. So what do we know about the relationship between 2x plus 10 and 3x plus 2? Yeah. Okay, so if I go 2x plus 10, that would be equal to 2 times 3x plus 2. Agreed? If I doubled EC, I get AB. Right? So let's work this out.
2 or 3.
Agreed? Okay, so I'm going to subtract 2x, so I get 4x over here. If I subtract 4, I get 6 over here. If I divide, I get 6 over 4. So I find that x is equal to 3 over 2. Agreed? So from there, if I take that and plug it in there, I get 2 times 3 over 2 plus 10. That's 3 plus 10. So I get 13. So this length here is 13 right here. Is that right? This is half of 13, or if you don't believe me, you can say, well, let's plug it in and see what happens. So I get 9 over 2 plus 4 over 2, which is 13 over 2. And I said that this side is half of 13, and I get 13 over 2. Oh, wait, that is half. All right, so this segment here is 6.5. I'm going to add that to 13. I'm going to add that to 6. I'm going to add it to 8 because I want to find the perimeter, and I get what? What? 33.5, I think.
Oh, okay.
Is that right?
I thought there was no decimal on 6.5, so I was like 60, but that wouldn't equal anywhere close.
Sorry, it wasn't the perfect circle of a dot.
No, it was my fault. I misread it.
Oh!
Why are you so excited?
You keep giving me a hard time.
I don't mean to give you a hard time.
I know. I've cried
Most
myself.
of the time.
I've cried myself asleep for the past 6 weeks. So. Same.
Whoa! I got
Huh?
so much problem.
It's funny that you think that.
As soon as the rest of the teachers get them graded and we can figure out the curve.
Oh,
Sorry, it's not my fault. It's not my fault. I'm a fast grader.
Wait, have you graded them all yet?
Yes.
He's waiting them all. He's just waiting for everybody.
Speaking as
every
the
other
child
teacher.
of a teacher, grading takes a long time.
I know. It
Did
took
ever
me
make you
7
grade
hours to
homework
grade them all.
When you were younger, did your mom ever make you do her grading for her?
I have no problem grading them. It took me a long time to grade. It's just
I
that other teachers weren't as fast at grading it as me.
old enough to.
Do you have a story for us?
Yes.
Okay.
Yay!
Story.
No.
So is the test on Monday going to be all proofs?
All right. Sure.
Okay.
It's just a section of the test. You won't tell. What the heck happened over there? I didn't even look at you when you were just.
Seamus got upset.
Oh, I thought you had a story for us.
What place?
All right. This kind of problem you saw on the test. It continues to wreak havoc with students. And I want to try and see if I want to clear it up a little bit. Okay? So I'm going to take this purple triangle here. Okay? So we don't know any of the angles, but we do know that X has to be one of the sides. So X might be the longest side, it might be the shortest side. I don't know. It might be the middle side, but if we incorporate the longest and the shortest sides, then the middle side will fall in between. So what does X have to be larger than?
9.
It has to be larger than 7 for the purple.
Oh.
Because 7 plus 3 is 10. It has to be bigger than 10 in order for that third side to be 10. Agreed?
Wait,
Yes.
I thought you said it couldn't be equal to.
It can be equal. It's got an equal
Oh,
out
really?
triangle.
I didn't know. I thought you said it couldn't be equal.
No, it's greater than 7. 7.0000 forever with a 1.
Well, no, I mean, oh, well, oh yeah, okay, that, yeah,
All right.
makes sense.
What can X not be bigger than?
13.
It can't be bigger than 13. So now X is going to be less than 13.
But what if it's the largest
So-
side?
So that would mean it was the largest side. If it's 12.9 repeated forever, that's the largest side.
Okay.
Okay? All right. So that's our restrictions for our top triangle. Agreed?
Yeah.
Now let's go back crayon. Let's go green crayon.
Why are you using crayon so much
I look because it smells good.
now? You can't even. It's a welcome change, but.
Okay.
Yeah, can we just do our final in crayon?
You always could do it in crayon. Heck yeah.
Could we get extra credit for it?
No. Just don't do it in lipstick. The lipstick smears too much. All right. So the green triangle. The green triangle. The green triangle. X has to be larger than what in order for this to do? Has to be larger than what? 9. But X has to be smaller than what? 19. So this works for our bottom triangle. Okay, so now, let's think about this. Let's pick, what's a number that's bigger than 7?
8.
8. Okay, does 8 work down here?
No.
No. So that one can't work. Agreed?
Agreed.
Okay, Let's pick a number smaller than 13. 12. Does 12 work here? Yeah, it's pretty content. I like it. It's going to work in this region. Okay. All right. Pick a number bigger than 9. Let's pick 10. Does 10 work up here? It certainly works down here. Pick a number smaller than 19. 18. Does 18 work up here? So this is my bound region. That's what X has to be. It has to be bigger than 9. It has to be less than 13. So if you're talking about the whole number gamut, it has to be, I said gamut, not damn it, 10, 11, or 12. Okay, if you're talking about whole numbers, right? So it has to be X is less than 12.9 repeating forever. It's bigger than 9.000 forever with a 1. Make sense? Cool.
How to cover up by
Be
saying
done
a
with
swear
this for
word.
now.
I didn't say blah blah blah.
We're
All right.
gonna have more.
So, things to think about. So tomorrow, that's Friday, right?
No, tomorrow.
I have 4 more proofs that you guys and girls don't have that I want to go over. I want to go over the exact same way that I went over them today. Okay? There are go-tos that we always have to say that can happen. Reflexive property always happens. Vertical angles always happens. And the last one that always happens is if you have a circle, you know that the radii always happens. Okay? So some of you, it might be great if you started looking at the proof, not as the whole proof, but as, okay, I'm taking a look at the diagram. What are my go-tos I can see on my diagram? That might be really important for you. Okay? And I think it might help a lot of you. Now, some of you who have the proofs down, keep doing it the way you're doing it. I'm just trying to present an alternative way of getting through it, which might get the, oh yeah, that worked. So reflexive all day long. Vertical angles all day long. And then if you happen to have a circle, you know that the radii have to be equal. Those are all day longs. And tomorrow we'll hit some of those. Okay? That's all I have for you. Okay. So just to reiterate, those of you who paid attention so well, we do have the first part of our final on Monday. What's on it? Geometry.
Thanks.
Okay? Then depending upon which class you're in, I think we have this class on Wednesday or Thursday? Wednesday. So Wednesday or Thursday are our 2 geometries. So what's on the test on Wednesday or Thursday, depending on what class we're in? Geometry as well.
Wait.
Really? I thought we were gonna be doing
But I'm doing it in Latin.
physics.
We're
Yeah.
doing